Hello everyone, so welcome to the lecture number 15. In this lecture we will discuss another theorem, that is theorem number 8.5. So let us understand the statement of theorem 8.5. Right. So according to the theorem 8.5 it is given, if in a quadrilateral, suppose ABCD is a quadrilateral, so if in a quadrilateral each pair of opposite angle is equal, right, then it is a parallelogram. Okay, so it is given that ABCD is a quadrilateral. It is not given it is a parallelogram. No, simply ABCD is a quadrilateral. Now in this quadrilateral, the pair of opposite angles are equal. Okay, so it means if A is an angle, then its opposite angle is angle C. Similarly, if B is an angle, then its opposite angle is angle D. Now according to the statement is given that the pair of opposite angle are equal. It means the angle A is equal to angle C, right? So this angle is equal to this angle, and angle B is equal to its opposite angle, angle D. So this angle is equal to, understood? So it is given. Now from this statement, from this information, we have to prove that ABCD is a parallelogram. Understood? So let us first write what is given here. So it is given that ABCD is a quadrilateral, not a parallelogram. It is a quadrilateral. Okay? So in which A is equal to C, right? Angle A is equal to angle C and angle B is equal to angle D. The pair of opposite angles are equal. So to prove, what do we have to prove? We have to prove that ABCD is a parallelogram. ABCD is a parallelogram, right? Okay. So tell me, how we can prove that any quadrilateral is a parallelogram? Which is the condition should be satisfied so that we can call a quadrilateral to be parallelogram? Let's think. If we can prove AD parallel to BC and AB parallel to DC, it means if we can prove the pair of opposite sides are parallel, this and this are parallel, this and this are parallel, then we can say yes, this quadrilateral is a parallelogram. So our main target is to prove that the pair of opposite sides are parallel. Okay, then we can prove that ABC is a parallelogram. So let us prove. How we can prove? See, since it is a quadrilateral, then the sum of the interior angle is how much? We have discussed that in a quadrilateral, the sum of all the interior angle is 360 degree. That means angle A plus angle B plus angle C plus angle D is equal to 360 degree, right? So angle A plus angle B plus angle C plus angle D is equal to 360 degree. We know it. Okay. Let's write it twice. Why? I will tell you later. Why I have written it twice, I will tell you later. Okay. Here also you can write A plus B plus C plus D is equal to 360 degree. Clear? So next. So A plus. So here you have to write B plus. So now in the place of C, can we substitute angle A? In the place of C, can we substitute angle A? Yes, we can substitute because C is equal to A. Because C is equal to A here. So in the place of C, we can substitute A. Understood? Similarly, in the place of D, can we substitute angle B? Yes, we can substitute because they are equal, pair of opposite angles are equal. So in this place, we can substitute B is equal to 360. You can write the reason here. Since there is no space, that is why I didn't write it. But you have to write in your copy, right? So, A, here A, that is 2A. Okay? Plus B, and here B, that is 2B is equal to 360 degree. Done. Now, take 2 as common. So, we get A plus B inside the bracket is equal to 360 degree. Clear? Now this 2 should be moved to the right hand side. So in the left hand side we have a plus b is equal to. So when 2 moves to the right hand side, it will be divided. So finally what we get? So finally we get a plus b is equal to how much? 180 degree. Understood? We get a plus b is equal to 180 degree. That means this angle plus this angle, right? This angle plus this angle is equal to 180 degree. Understood? Now consider that you can see AD and BC are two lines, right? And AB is a transversal line. Let's see. This is AD and let's say this is BC. And AB is a transversal line. Okay, so let us write it here. AD and BC are two lines and AB AB is a transversal or AB is transversal. Now, if these two are straight lines and AB is transversal line, then these two angles are known as what? These two angles. This and these two lines, this is the transversal line. Then these two angles are known as what? Tell me. See, it is like this. Then these two angles are known as what? They are known as co-interior angles. What are they? They are co-interior angles because they lie inside the two lines. Okay, and towards only one side. That is why they are known as co-interior angles. Understood? So angle A and angle B are co-interior, right? So angle A and angle B are co-interior. Understood? But from equation number 1, what we have got? What we have got? We have got that this angle plus this angle is equal to 180 degrees. That means the sum of two co-interior angle is 180 degree. Here we have found A and B are co-interior and we have found the sum of two co-interior angles is 180 degree. Then remind the theorem number 7.6. According to the, sorry, this is 6.6, right? 6.6. So according to theorem 6.6, we know if there are two lines, okay, and in a transversal line, if the sum of any two co-interior angle is 180 degree, then these two lines are parallel. Okay, this is theorem number 6.6 or 6.7, whatever it is. Okay, so here we found that the sum of two co-interior angles is 180 degree. So what we can write? We can write this side AD is parallel to this side BC. Okay, so you can write AD parallel to BC. Actually, I have forgotten which exactly theorem it is, so I have to write theorem. I think 6.7 या फिर 6.6 या फिर 6.8, whatever it is. So finally we have got that AD is parallel to BC. Clear? Now it is done. Coming to the second step, second column. Here also we know sum of all the four angles 360 degrees. This is clear. Now here you can write A as A. Now in the place of B, can we substitute D? In the place of B, can we substitute D? Yes, we can substitute because B and D are equal. So in the place of B, you can substitute D. Right. Next, in the place of C, can you substitute A? Yes, they are equal. So in the place of C, I substitute A and D becomes like D. So here we get A plus A, that is 2A, D plus D, that is 2D is equal to 360 degree. 2 taken common, right? So A plus D is equal to 360 degree. Then 2 moves to the right hand side. So in the left hand side it will be A plus D is equal to 2 moves to the right hand side, it will be 360 degree by D. Okay, now cancel it. We will get 180. So finally we get A plus D is equal to 180 degree. This is our equation number 2. So which two angles sum is 180 degree? This angle plus this angle. This angle plus this angle, right? Now let us consider AD. Okay, Yes, let us consider AB and DC, right? Which two sides? This is AB, okay, and DC, right? DC. Okay. Now AD is what? AD is what? AD is a transversal line. These are two lines. AD is transversal. Okay. Now here we have found that this angle plus this angle. That means this angle plus this is equal to 180. Now tell me, if there are two lines and there is a transversal line, then these two angles are known as what? They are co-interior. Like this, they are also co-interior because they lie inside the two lines and in the one side. So they are co-interior. Okay. So let us consider which two sides? AB and DC. Okay. So AB and DC are two lines. AD and AD is transversal. Then this angle and this angle are known as co-interior angle. So angle A and D are co-interior. Understood? But what we have found in equation 2, we have found that the sum of these two co-interior angles is 180 degree. Okay? But we found what? A plus D is equal to 180 degree. But we found A plus D is equal to 180 degree. That means the sum of two co-interior angles is 180 degree. Then now, according to the theorem 6.7, we can say if in a if there are two lines and there is a transversal line and the sum of two co-interior angle is 180 degree, then the two lines should be parallel. So hence you can write implies AB, that means AB, okay, is parallel to DC, here DC. So correlate this figure with this figure, okay, don't be confused. For your better understanding, I have drawn this figure, okay. So here we have found that this angle plus this angle is 180 degree and they are co-interior, that is why, and these two lines are parallel. So initially we have proved AD parallel to DC. Now we have proved AB parallel to DC. Let's say this is equation number 3 and this is equation number 4. Okay. So initially from equation 3, what we have got? We have got AD parallel to BC. That means AD, this side is parallel to this side BC. AD parallel to BC. And these two sides are pair of opposite side. Yes. And from equation 4 we have got that AB, this is parallel to DC, this side. That means this side and this side are parallel. And these two are also pair of opposite sides. So finally what we got? From equation 3 and equation 4 we got that the pair of opposite sides are parallel. Right? So you can write. So from equation 3 and 4 we got what? Pair of opposite sides are parallel. Understood? So here this parallel to this and this parallel to this. It means what? It means definitely ABCD is a parallelogram. Implies ABCD is a parallelogram. Okay. As I have told you, if we can prove the pair of opposite sides are parallel, then it is a parallelogram. So here we have proved this. Hence, ABCD is a parallelogram. Okay. So now it is proved. So what we learn from this theorem? We learn that if in a quadrilateral any pair of opposite angles are equal, then definitely this quadrilateral is nothing but a parallelogram. Okay.